Hello everybody. So let's take a look at this next lesson. So I want everybody to go to page 59. I'm on page 59. So we're going to look at all of these story problems. I know everybody loves story problems, but I'm going to try and help you out with them. So I'm going to read it through it with you. I'm going to set up the problem, and then I'll have you guys do the rest of the work. So let's take a look at the first problem, okay? So read along. Splish Splash Pools creates a community pool for a housing development. The rectangular pool has one section with a 4-foot depth, another section with a 9-foot depth. The pool also has a diving board that is 3 feet above the edge of the pool. And then it extends 5 feet over the pool. Okay, so this is like 3, and that's like 5. After doing some research, Split Splash determines that the average diver is 5 feet in the air when they are 8 feet. So right about there, they're going to be, maybe 5 feet in the air when they're 8 feet away from the pool. That's like a 0.85. And 6 feet in the air when they are 10 feet from the pool. So I don't know if that's over here, but it's higher. So I'm going to say maybe something like that. And so I've got a 6 feet out and 10 feet in the air, okay? So what I did is I just kind of tried to make a graph of this, and I put the axes right like here, okay? And these are like points, so let me redraw this as a graph. It's kind of a hard problem, but I'm here to help, okay? So 0, 0 would be like right about there, okay? 0, 0 is right about there. So at 5, 3, is right there standing on the edge of the board. That's my 0.53. And then, as they jump up at a point 8 feet out, 5, 6, 7, 8, they'd be 5 feet up, so I'd have a point at 8, 5. And they get one more measurement, 5, 6, 10. So out 6. So this got to be 10, 6, obviously, because that's not going to work. 8, 5, 3, 8, 5, 6, 10. 6 feet away, 6 feet in the air when they are 10. So yeah, this is a 10, 6. My bad. It's a 10, 6. Let me fix that to a 10, 6. There we go. So it looks to me like it's probably going to be some kind of a parabola, because the obvious person is going to go back down. And so what you've got to do is come up with the equation. So I've got equation 1, equation 2, equation 3. And your job on this one is to solve it like we did the other day with 3 points, right? 3 points. 3 equations, okay? All right, let's take a look at number 2. Okay, so turn the page, take a look at the next one. Okay, so the next problem, slightly different, because we have the amazing Larry is a human cannonball. He wants to reach a maximum height of 30 feet during his next launch. His assistant, Juan, estimates that this will occur when Larry is 40 feet from the cannon. When amazing Larry is shot from the cannonball, he is 10 feet above the ground. Okay, so let's see if we can draw a picture of that. Okay, so he's going to be shot 10 feet. So he starts here at 10 feet, right? And he's shot up, right? It's like a quadratic to me. We know that his maximum height is 30 when he's 40 feet away. So that would be the vertex at 40, 30, okay? So then, again, I want you to find the equation, probably vertex form, because you got a vertex there. The equation for amazing Larry, okay? Moving on. Number 2, Crazy Cornelius runs and jumps through a ring of fire. He runs for 10 feet. Then he begins his jump just 4 feet from the fire and lands on the other side 3 feet from the fire ring. When Cornelius was 1 foot from the fire ring at the beginning of his jump, he was then 3.5 feet in the air. Okay, let's see if we can draw a picture of this one. So, oh, that's bad. So let's see. At 10 feet he jumps, right? And then there's the fire ring. The ring of fire's got to be in there somewhere. So the ring of fire's right in there. Here's my ring of fire. Let me make it look like fire, okay? Just make it look like fire, like make it red. Yeah, here's my fire ring. So he begins his jump just 4 feet from the fire. So that means this would have to be at 14, right? 4 feet there. And lands on the other side 3 feet from the fire ring. 3 feet from the fire ring. So that'd be at 17. He lands at 17. So we draw this down. So 17 is actually right there. That's 17 there. Okay. And 1 foot before the ring, 1 foot from the fire ring, he begins his jump. So that'd be like right here, 13. He begins his jump. Okay. He was 3.5 feet in the air. So this would be at a height of 3.5. Okay, so let's see what we have. Looks like we might have roots, and we have another point. Our second point would be at 13, 3.5. Okay, I'll let you guys figure that out, but I would definitely use root form. Here's my two roots, 10 and 17. And here's a point to plug in some x and y value. Okay, your homework is going to be to find the equation. Okay, now let's move on to this one. Okay, 3. So Harsh Kanash jumps across an alligator filled swamp. Sorry, Harsh Kanash jumps across an alligator filled swamp. She takes off from a 30-foot high ramp with a speed of 95. Now they give you an equation, and hopefully we'll talk about this in our vocabulary. But we need this equation. We need this h of t equals negative 16t squared plus v0t plus h0. Okay? v0 is your initial velocity. How fast are you going? Okay? 95. That's my v0. How fast am I going? That's my v0, my initial velocity. h0 is your starting height. Right there is my h0. 16t is always the same. That's just gravity. That's gravity on Earth. Okay, unless you go to a different planet, that's gravity. Okay, so I'm going to use this equation. H of t equals negative 16t squared plus 95t plus 30. Okay, so write a quadratic equation to represent Harsh Kanash's height in terms of time. I've got that one done for you. Now, down here, though, you're going to recreate this formula, but with Slugger. Van Slugger needs one more home run to advance to the next round of the home run derby. On the last pitch, he takes a swing and makes a connect. Initially hits the ball at 5 feet above the ground, 32 feet from home plate. His ball was 23.5 feet in the air and 220 feet above home plate. His ball was 70 feet in the air. The ball needs to travel a distance of 399 feet. Okay, that sure sounds like 3 points, doesn't it? So, actually, we're not going to use this one. I was wrong on that one. First, let me take that away. You're not using this formula. There's no velocity. My bad. Get rid of that. I'm not going to use this one at all. So, you're going to actually have to use 3 points. I think 1 point has to be at 0.5. We've got another point at 23.7, right? 32 feet plus 23.5, so that's a second point. 23.7. And then we got another point. And at 220 feet from home plate, his ball was 70 feet in the air, so probably right about here maybe. That's a 220 feet and 70 feet in the air. Okay, so again, you've got 3 points. Point A, point B, point C, and you would have to do the 3 equations, 3 unknowns to get an answer. Okay. All right. and then you have to find out what the maximum height was and whether or not he makes a home run, okay? Maximum height, I would use the negative b over 2a. It'd probably be the easiest formula to use on that one, okay? So your homework is to complete these. I have set you up. On number 1, you got 3 points. Number 2, you've got a vertex. Number 3, the third one, actually it's number 2 really. You've got the intercepts or the roots. Number 3, you've got the velocity equation, and then number 4 is the 3 points. Okay, so that's what I have for you. I will see you guys soon.